Alright, here we go. We're going to start this video off with 1/5, just to kind of get used, continue with this pattern here. What goes? 1 goes in the house, and then 5 goes outside, and that's what we're dividing by. And we want to figure out how many 5's going to take out of 1. We can't do it, so we need to add a 0. But before I do, I'm going to add that decimal point before I forget. Now, how many 5's in 10? Well, hopefully, we know that's 2. And then multiply, put answer in bottom, subtract. We've zeroed out, so we're done. So 1/5 is the same as 0.2, or I can put that 0 there, 0.2. Next problem, let's look at 3/5. And again, we're going to convert this to a decimal, so we're going to divide the numerator by the denominator. Okay, so how many 5's can I take out of 3? I can't take any because 3 is too small. So what I'm going to do is I'm going to add my decimal point, and I'm going to add a 0. Now, how many 5's can I take out of 30? Well, 5, 10, 15, 20, 25, 30, that's 6. Put answer on top. Now I'm going to multiply, put answer in bottom, subtract, double 0, so I've terminated it. Okay? Final one we'll look at, for this one at least, let's look at 4/5. I'm going to set, we want to, again, convert to a decimal. So numerator is under the house, 5, denominator is outside. And we ask ourselves, how many 5's can I take out of 4? None. So what I have to do is I have to give myself a decimal point. I'm going to add a 0. And now how many 5's out of 40? That would be 5, 10, 15, 20, 25, 30, 35, 40. That would be 8. Multiply, put answer on the bottom, subtract, 0 out, we're set. So 4/5 is 0.8. Okay, so 1/5 is 0.2, 3/5 is 0.6, 4/5 is 0.8. Alright, so those are kind of what we call terminating, which mean they end. We get to a double 0 eventually. Now sometimes it takes us a while to get to the double 0, but sometimes we never get to double 0. So I want to show you a few that never get to double 0. So let's look at 1/3 here. 1/3, and we want to convert that to a decimal. Again, numerator goes in the house, 3 goes on the outside, denominator goes on the outside. First thing we're going to do, how many 3's can I take out of 1? 0. So what I'm going to do is I'm going to add my decimal point and how many 3's go into 10? That's 3. 9, subtract, 1. Bring down to 0. How many 3's in 10? 3. 9, subtract, 1. Bring down to 0. 0. How many 3's in 10? Now, boys and girls, at this point in time, I hope you recognize that there's a pattern here. Every time I do this, I'm going to get 10, then I'm going to subtract 9, and I'm going to get 1, and I'm going to get 10 again. So what we have here is we have what's called a repeating decimal, which means this 3 is going to go on and on into infinity. If I had enough room and I had enough time, I could keep doing this, and I would keep getting the same thing. And it would still be 3, 3, 3. So what we do is, because it's non-terminating, it's repeating, we have to figure out which digit is repeating. Well, boys and girls, what digit it is? It's 3. So what I do is I write 0.3, and I put a line over the 3, knowing that the 3 is a digit that is going on and on and on into forever. Okay? Let's look at another problem here. We have 2/3. Actually, you know what? We're going to not do 2/3. Let's do a better problem here. Let's do 5/6. Okay? Which, when we look at it now, becomes 5 in the house and 6 on the outside. So now we're going to multiply that. Oh, not going to work. I can't take any 6's out of 5, so I'm going to add the decimal point, add my 0. What do we got there? Well, let's call that 8. Okay? And we're going to subtract, because 6 times 8 is 48. That's 4, 2. I'm going to bring down a 0. Okay, how many 6's in 20? That's 3. And that's 18. Subtract. 2, add a 0, bring it down, 0. Now, hopefully at this point in time, boys and girls, you're going to see this pattern here, because this is going to be 3, 18, subtract, 2, bring down a 0. Oh, look. Now, when you see this same thing that's going to happen, like right here, 20, 20, 20, you know you've got your pattern, and you don't have to do any more. So in this case, what's repeating is not the 8, but the 3. So we put the lines over the 3, and we leave the 8 unmarked or whatever, okay? So 5, 6 as a decimal is 0.833 continuous, which means the 3 go on and on into infinity. All right, let's look at one more. Let's look at 4 ninths. And then we're going to set that equal to 4 in the house, and we're going to divide by 9. Okay. How many 9s can I take out of 4? That would be a big 0. So let's add a 0. How many 9s can I take out of 40? Well, 4, 9, 9, 18, 27, 36, 45. 45 is too big, so we have to be talking 4. Multiply, put answer on bottom, that's 36. Now we're going to subtract. 3, 10 less 6 is 4. Bring down the next. Oh, no numbers, so we have to add a 0, bring it down. How many 9s out of 40? Well, last time it was 40, so, or 4. 36. Subtract. 4, because that's 3, 0, 40. Now, how many 9s in 40? Wait a minute. We've asked this question once here, twice here, and this is the third time. So have we developed our pattern? Yes, we have. 4 ninths is 0.44 continuous. Okay? So what you have to do, boys and girls, is you have to try and find the pattern, whatever pattern that might exist. Now, you need to find that pattern more than once, because if I would have done this here and thought, ooh, that's the pattern, I wouldn't have the correct answer. Okay? So you have to try at least probably 3 times where you get the same response. All right, so that's the video number 3. We talked about just normal numbers here, normal terminating numbers here, but then we also talked about repeating numbers here, and you're going to run into both in your homework. All right, video number 3, I've got some story problems for you that are practice.